In the previous video, I showed you how we can create a somewhat realistic looking wood material by using the procedural textures of the node editor. So we actually can create an interactive wood material that works like a volume. So it's a 3D material, not a flat surface 2D material. So now it's time to apply this material onto our blend file, where we have all the geometry of our garden chair. The problem, however, is this is a different blend file. By the way, in case somebody asks how I do this, I simply have two different blenders open. This is something I do very often when, for example, I work with two different files. Blender can only have one file open at the same time. So this file is called Wood 3D New. And to get this material over into my other Blender file, we can use the file append. So I will go to the chair model, go to File, Append, and then it will open the file browser. I am currently in the folder with my wood palette chair, so I click on the arrowhead to navigate up. There's my folder 2D 3D wood, and there is my 3D wood blend file. Now when we select the link or append function, we can look into a blend file. So when you click it, you see it opens the structure. We would like to import a material, so go to the materials folder, and there is Wood 3D. You can click it, you see it selected, and then we say append from library. Click, and you're back. So now I can select, for example, let's say this lumber part or the element, go to the material, and then here we say 3D Wood New. And you see then it gets applied or added to it. You can do the same there. And we can do the same for the backrest. These are all three individual objects, so each one we have to give the material. With the with these three arrays, which define kind of like these wood planks we sit on, things will work a tick different. If you have everything set up correctly with duplicates, you will see when you add a material, the other two objects are colorized or have the material applied to at the same time. So why happens this? Well, the thing is, we have a material slot created and then we loaded this Wood 3D. And you see this is used 4 times. 1, 2, 3, 4. Well, we actually have 5, 6 objects. But you see that this material is linked to the data of an object. Again, the object is just a 3-dimensional container into which we can insert geometry. So you see the geometry here is this plank. Now, if we go to the data panel, so to take a look at the properties for object data, you will see that wood plank is something all these 3 objects share. Well, they're all linked or clones. And to this wood plank data, the material is linked to. That's the main reason behind it. We can actually go to settings and, for example, for the viewport, maybe give this a different color. This is not a color that can be rendered, but this, for example, helps to quickly see visually different components or objects. So in Fusion, for example, we can colorize components, so we easily see all the logical groups. And here we can, for example, if we have steel, give all steel objects a certain viewport color. So via the color, we can really see maybe what material we are using. Okay, perfect. So before I continue, I touched upon this idea of the data. You see a link to data. If I say link to object, you see now this one actually has a different material, or basically it's an empty slot. I can make a new material. Let's say I make this one red. And there you see the material for this object is linked to the object, and the data for, the material for these two objects is linked to the data block, so to the mesh. And if I move this point, you see all objects have the mesh updated, but they don't, all three don't share the same material. And if I switch back here to data, there you see now you have the same material again. So mesh can be shared among different objects, and then for each object you could say have an individual object material, or link the material to the mesh data, and then this way you can also link the material between different objects. Okay, so let's bring this one back. Perfect. So before we continue, I would like to slice this one, load my node editor, zoom in a little bit, and let's take a look at the object in render time. So Shift Z, or go to viewport shading and rendered. Okay, so there's actually one problem, and you can see the orientation actually of our meshes is not correct. Or we could say the orientation of our wood material is not correct. So for example, let's work with this one. When you press H, you hide an object. Alt H, you show the object. If you have an object selected and you press Shift H, then you hide everything else besides what you have selected. I also, for the rendering, have a Studio HDRI loaded. So the very basic setup: environment, texture, background, and load that image onto it. Okay, so let's do rendering, and let's take a look at what's wrong and maybe what we could do differently. So you can see the rings actually here at this side, but I actually want the rings to be on the shorter part, because the piece of lumber here or timber is actually cut out of a tree more like this. But currently, the way how the wood grain looks like, it feels the piece was more cut of it kind of like this way, and that's not really what I want. So what can I do? Well, if we take a look at the texture coordinate system, there are rotation values we could work with. But let's maybe try this one out. So you see X, that is a direction, so properly Z is what we have to play with. So let's say 90. Does this do it? Let's zoom in a little bit, and you see, no, it didn't really do it. What about X? Also didn't do it. And what about this one? Also didn't do it. What about we play with all? Also don't really do it. Okay, so what's the problem? Well, the thing is, the direction of the grain flows along X. I have my object selected, and you see in local space X goes this way, but I want actually X to go vertical. So what I would have to do is the following. We do a little trick. So Shift S in object mode, cursor to selected, so that actually now my cursor is right where the object center point is. And then we go into edit mode, AA, select everything. Make sure you have the 3D cursor selected. So you see it switches back to this position. And then in my case, along the y-axis, I rotate this one. So R, Y, 90, press enter. Okay, and now you see my wood piece grows along the x-axis. If I do a quick rendering and zoom in, this is actually more what I want. But now this object is rotated. That's not really what I want. So in mesh mode, we rotate the mesh so it really grows along the x-axis, and then in object mode, we rotate it back. So R, Y, minus 90. There. Let's do a rendering, and there, that's what we are looking for. Okay. Perfect. Good. So this might have been a little bit confusing for beginners. So let's do this one more time. We will do the same now with this part. So select this one, Shift H, so we hide everything else, and go in. Let's do a rendering, and there you can see that the rings grow along this side, but I want the end grain only to be on this face. So in object mode, Shift S, cursor to selected. We are in 3D cursor mode. Go into edit mode. Just make sure you select everything, and then R, Y, maybe 90. Okay, leave edit mode, and then in object mode, R, Y, the opposite 90. Before I rotated Y positive 90, so this time I need to R negative 90. Press enter. You also see in local space now how the x-axis actually grows again or flows along the object, and that is correct. And there you can see now the correct orientation. Perfect. Alt H to show everything again. Shift H, Control S, cursor to selected. Now this one is rotated 15, so let's keep this in mind. We first set this to 0, so it's easier. So edit mode, AA, R90, but along the y-axis. You see I typed in R and 90 and it did this. I forgot the axis definition, R, Y, minus 90 or 90, doesn't matter. Okay, object mode, R, Y, the opposite 90. And then this, for example, was rotated 15 degrees. So now you see here I have minus 90. Now I can see when I lower this, then it goes backwards. So minus 90 minus 15 degrees is minus 75 degrees there. Let's do a rendering. Okay, also this looks good. Alt H, show everything. And now we have to take a look at those. 105, so maybe let's set this to 0. Okay. Let's do a rendering. Now we can see how this looks. And this is not really ideal, because this end grain we want to have here on this side. So there are a few things we have to do. Shift S, cursor to selected, go into edit mode, AA, and then we type in R, Z, and 90. And you see I rotated the plank so that it again lines up with the x-axis. Then I can tap edit mode, or press tab, and then RNZ and 90. Let's take a look. Yeah, this actually works better. Along the x-axis we had 105, and this is good, okay. But now we have this happening. So what's going on? Well, this is no big problem. We just changed the orientation of the mesh, and we just have to update the array modifier. So if we go to the array modifier, you see that it uses x, y, and z, and it uses x. But we want actually to use y. 1.2, so 0 for x, 1.2, wrong direction, so minus there. Finito. Let's take a look here. So also this one, we can just R and Z. Before I do this, you notice I switched actually from the 3D cursor back to here. So when I click the object, I rotate around the object's center point in this case. R, Z, 90. And then 0, 1.2, and okay, negative. Let's take a look. You see also that one is correct. Okay. Then this will be the last one. You see the z-axis here is now horizontal. So this is global. So R, Z, Z, and 90. And 0 and minus 1.2. Okay. So let's take a look. And most of that stuff is okay. Good. So the textures flow actually now correctly. There is, as it seems, however, there one tiny problem. There I have a problem. There I have a problem. Okay, so it's actually good that this failed, because now I can show you the downside of the initial version I showed for how to make the joinery by making clones actually of this block. And then, you know, in the appendix for wood joinery, I used custom built wood blocks, which actually work better. So because I went into edit mode and I rotated my geometry, that also means that all my elements that, for example, do the cutting are rotated as well. So that's not really ideal at all, which is not really a big problem, because as I said, that was the first way how I showed it to you, and then later I decided there's actually a better way, and maybe this now shows you a second reason why we even should actually want to use that other way. Okay, so I will just try to readjust the first part, and then I will simply pause the video, finish the design, and then we can continue and move forward. So this one I delete. So there's the object. Shift S, cursor to selected. Let's create a plane. Maybe scale this plane down a little bit and move this to there. Perfect. Let's show this one. And to work really nice and precise, I should turn off the bevel command, so that when I do my snapping, I snap really only to the edges of these timber blocks. So this object, by holding Control, I can snap now to this edge, and this edge I snap to this one, so you see it's actually just using this back edge. Perfect. AA, S and Y, scale to the center, and again, for those operations here right now, I do not use the 3D cursor. And now we can slice this one. So K, hold Control. Oh, I snap actually to the edge. Maybe K. See, that's okay. So when we do the knife tool, if we want to snap to the midpoint, have the vertex maybe selected. K, Control, click, and click. That's one way. Or we can press Control R, select this edge. You see now we can move it, and then we press 0 so that it's in 50% position, and press Enter. Good. And then this one, E, we can drag up a little bit. Good, this happened. Perfect. And then this one, for example, we can press P to separate. Because you see, in case you do this, there's an opening. So we can easily select these two edges or these two edges and then press F to fill the face. Press A to make sure everything is selected, or AA, and then go to shading UV, and we say recalculate. Perfect. Goody. Now we have to go to here, select everything. That's the other second object. E, extrude it up. We can snap to this height. Let's check. Okay, there, it didn't open that face. AA, just to double check, recalculate. Good. And best practice, front leg, or actually I call this one Boolean outside, and this is Boolean front leg inside. So now which object is which object. And then for this one here, now I can decide which one I want to work with. I will show the joints. So I will, in this case here, select the inside, because for this part I will select the outer cube. So there you see, you will see the joint later, the half flap. Great. Okay, so one thing I would like to show, this might be nice to know about the Boolean modifiers. You see there we have this object, we make a mirror, and there we cut something out, but it's not really cut out there. So, why? That's kind of stupid. Well, the main reason is we have the mirror and then the Boolean modifiers. So let's say this is actually joint, and this is actually, I call this one floor because we trim it. Okay, good. So how do I now make sure that this joint Boolean also shows up on the other side? Well, this is actually pretty easy. We simply have to move this one to there first, so that the joint adjusts this part, and then we mirror it over, and then both results, for example, we clip. To make it a little bit easier for the software, we will actually adjust everything this way. So we have a basic object, we cut this one joint part out, and then we trim the bottom, then we round everything, and then this end result we just mirror over. Okay. For example, here we can do a similar thing. So the mirror here, simply we move completely to the end. Perfect. Good. Nearly. Shift H, and there is a problem, as you can see. Okay, Alt H to show everything, because this one cube here is not overbuilt enough. So I simply either in object mode, or I could also go into edit mode, move these two edges down. So you see it overbuilds nicely along all the important faces. Let's hide it there. Perfect. there's only one problem left. It might not necessarily be noticeable to you, but let's go to this view. Let's zoom in a little bit. And no, where can this better be observed? Let's see. Yeah, maybe in the front or down there. Ah, this is perfect. You see here, for the vertical front legs, for those, if we zoom in, turn on the rendering, you see there's the ring. It starts, and then here we have kind of like a line going through the mid part, but this is actually an arc, but these are all the wood rings. So the problem is, because of the mirror command, it does not make two objects with their own unique materials. It is basically one big object that gets textured. So this sounds a little bit confusing, and let me do this so you understand what I'm talking about. So let's say we draw something like this, and then this, and let's make a box. You see, I can put this box around these two legs. That's called, or think about this as the texture space. You also see here's one object point, there's no other object point. So inside the mesh edit mode, this mirror command generates the other mesh on the fly, but we are dealing only with one object, which is why when we do a rendering, we have here the center, and then there only we have a line, because also our mapping control here currently is set to this position. So how do we fix this? Well, there are two ways. One way, we simply try to offset the center point to somewhere more in the center, so left and right we get something similar. So this is the y-axis, so I probably have to move this along y. Very small number maybe. Oh yep, there you see, minus 20 inches maybe. Ah, there, here you see, this looks a little bit better now. And because, again, this is a shared material, all other objects got exactly the same treatment of the material as well. So you will see that here and there, this is also a little bit more similar. But try not to make this one at a value so it's really the center point between these two objects, because then left and right might look too much the same. Okay, let's take a look from the front, because I'm curious if those brackets, or not brackets, planks, have exactly the same texture. And you see, in this case, it doesn't actually matter much. It looks pretty good. So if we zoom in, there's roughly somewhere the center point, and you see the rings grow down. So we get away with this limitation. We don't really see much of a problem. Okay, good. And to be honest, because in a rendering we most times only see the object from one side, we don't really show perfect symmetrical views most times, because that's very boring. It might not matter much that the other part nearly is textured the same way. Plus, in this case here, it's even actually hidden by all the wood slabs we are sitting on. So at this point, we, for example, could rotate this one back maybe to a nice 20% or 20.5. I'm not sure what I had. Okay. And why is this one plane so short? Okay. I'm missing this one cut here. I only had it turned off. So trim floor. Perfect. Good. So the object is rotated, and because the texture is actually using the object's orientation, you see now it also flows with the rotation value of our object. So we don't have to deal with a material that only goes strictly along the x-axis. The material, because we used this object as a texture coordinate, uses the local x orientation of our object. So we can always rotate it, and you see the material updates. There's actually one other way how we can define or manipulate the position, rotation, or scale of a three-dimensional wood texture. The advantage of the current method, which I showed you, by in edit mode rotating the mesh correctly so that in object mode we can position the piece of wood as needed, is we have to one time set in edit mode the mesh growth direction correctly, and then we are free in object mode simply to rotate the object, and it all the texture always rotates correctly. The secondary way is by using the object center, position, and rotation and scale function and copy it to our mesh. To our material. So the texture coordinate system currently uses the object, so the object orientation of our mesh part or the object here. So let's actually add an empty, and the empty I position right at this center point of this wood part. And then here in textures you can see object, we can borrow the position of this empty for the coordinate system. So let's go ahead and do a rendering. Okay, so what happens when, for example, I move this one to there? See, there's actually now the center of the ring. So wherever this object is the center, or I can move it even to here. There you see, for example, now the center is coming soon on the plank. And there it is. There. Okay, so let's say with S I scale the empty, and you see actually the scales now the veneer, the rings, because the scale factor for the empty is kind of like doing the same as with the mapping node with the scale. If, for example, we rotate this one, you see also there the wood grain goes and grows into different directions. So that's actually pretty nice. Okay. There's only, unfortunately, one particular problem with this, because this is one material and this material uses this empty. Now for this one object, not a big problem. Alt H, and then we see everything, and instantly you start seeing the problem. We adjusted this texture for all parts, but that's not really what we want. So I'm only showing you basically how this works so you understand the concept, and then you will realize why the first version I showed you actually is more economically friendly. This version I'm going to show you now, so version 2, artistically can maybe have a little bit more usability, but also is a little bit more work. So let's, for example, say this is actually empty back leg. Okay, good. Let's Shift D, and then we actually say this is empty front leg. Good. Okay, perfect. So in front leg, let's move this one down a little bit. So, Shift H, wait, hold on, no, it's okay. We only want to see this one. So the problem I have now, and maybe this is a nice situation to also explain you the power of nodes even more, is with nodes we can even have, for example, groups. But the cool thing about groups with nodes is a group can be shared among different materials. So essentially, this node, texture coordinate, always has to be unique with an object information. But then the rest of the texture definition or the material definition I want to be always the same. So what I will do is I select all this, for example, and then press Ctrl G, tab, and you see now there's a node. And the node has two vector inputs. If I go tab, you see I can open the node. Let's maybe go full screen so you can see everything. So the group input and the group output. Okay, so for example, if we go into edit mode, so with tab, it's now group edit mode. The first vector, for example, here we can click and let's say this is for mapping. And then this is maybe mapping 2, or for example, the Voronoi and the wave texture. And then here we could give this a name for the output. Okay, when we now press Shift A, you see there's something called group, and there's node group. So for example, here we could give this one a name, wood texture 3D, Shift A, group wood texture 3D. So where is this now going to be useful? And you will see. So this one, you see this material has 4 users. I click on the 4 and make it a single user. And then there I will say empty front leg. Okay. Then Alt H. I want to take a look at this one. And let's go to here. And this is empty back leg. But you see it uses the same group. So you see the groups are actually the same. So the nice thing is, if let's say I go to here and I just put in a 20 there, then I select this one, go to the group, and there's a 20. So you see, via the group you can share a shader among different materials. So one material can have something in common with a different material. So the node idea of weaving relationships does not only work inside a material, it even via groups can work across materials. Which is why in our case we need a unique texture coordinate for the object, and then we can have a shared material definition. So this one has empty front leg, this has the back leg. Let's hide this one. This is the back leg. There's a front leg. So this one, for example, I have to rotate R and 90. So wait, or yeah, correct. Shift Z. Let's take a look. And there, see, adjusted. Nice. So now I can, for example, select this empty and make it bigger. And then you see the material definition is exactly the same for all these wood parts. However, because this empty, which is being used to create the texture coordinate for this front part, is bigger, the material also will look bigger, but it has the same colors, etc. So you see now, I would have to do the empty thing for every element that uses a material. which then later, if I want to adjust maybe individual objects in 3D view, I could just move around these empties. And I don't have to go into each material and adjust something there via values. Visually, I can drag elements that then drive changes inside the material. I don't require you to try this one out. Maybe just take a look if you're curious, and then you can see if it's something you even might rather prefer working with or not.